Okay, so now let's look at what we have. So we're now given a P that's connected to a block 3. This P, it's on a surface. Let's assume it's a table. And this 3 kilogram block, it's hanging. So they're telling us that initially, okay, and they're connected by a light inextensible string, right? So what does light inextensible string tell us? It tells us that this is a frictionless pulley. The tension over here, it's equals to the tension over here, right? I want you to note that because it might help you in other questions, right? Okay, so we're being told that this 3 kilogram block, initially it was at rest, right? And then when it was at rest, it was suspended 0.5 meters above the ground. So its distance between the ground and where it currently is right now, it's 0.5 meters, right? So then this 3 kilogram block, it was released. When it was released, it took it what? It took it 3 seconds to hit the ground, to be at the ground level, right? So currently that's all the important things that you should note. And they also said ignore air resistance. We know that if they say ignore air resistance, what is it? It's a free falling object, right? So A, they're saying calculate the magnitude of A using equations of motion. So let's note all the things that we have. For A, we have T equals to 3s. We have VI, which is equals to 0 meters per second, right? And then what else do we know? We know the mass is not really necessary. We know change in Y. Remember, this is a vertical projectile motion object, right? So it's in the y-axis. So you can't say you know the change in x, because change in x, it acts along the x-axis. This is something that's acting along the y-axis, right? So we know our change in y to be what? To be 0.5. Okay, over here, I'm going to put all of our equations of motions, and you choose which one is the suitable one to use, right? So we have one that's changing x equals to, wait. See, I just made that mistake. We're supposed to say change in y, not change in x, because it's acting along the y-axis. So we have change in y equals to vi multiplied by change in t plus 1 over 2a multiplied by t squared. Note these down if you don't have them, right? This is the first one. And then for the second one, we have vf squared equals to vi squared plus 2a. Change in y, right? And then for the third one, we have change in y equals to vf plus vi all divided by 2 multiplied by change in t, right? And for the last one, we have number 4, which is vf equals to vi plus a multiplied by change in t, right? So when we're here, we just have to look, because what are we trying to find? We're trying to find our acceleration. This is our unknown. This is what we're trying to find, right? So we need an equation whereby the acceleration is present and all the other ones that we know, they're also present, right? And if you carefully look, we could just easily use the first one that we have. So we're going to say change in y equals to vi multiplied by change in t plus 1 over 2 multiplied by a multiplied by t squared. What is our change in y? It is the distance from the ground, right? Which is given to us as 0.5. So it will be 0.5 equals to, we have vi, which is 0. Remember, it was stationary at first, multiplied by, what is the time? 3 seconds, plus 1 over 2 multiplied by the acceleration multiplied, what is the time? 3 squared, right? So you're going to have 0.5 equals to 1 over 2 multiplied by a. What is 3 squared? 9, right? So you'll have your 9 over here. Don't mistake them for one thing. And then you can just divide both sides by 9, divide this by 9, this and this will give you a 9. So now you'll have 0.5 divided by 9 equals to 1 over 2 multiplied by a. But remember, we're not looking for 1 over 2, a half of a. We're looking for a. So you can multiply this by 2 to get rid of this 1 over 2, because if you multiply by 1 over 2, these two will cancel one another. And remember, what you do here, you also have to do this side. So we'll multiply this side as well by 2 over 1. So you'll have, therefore, a equals to, if you put all of this into your calculator, it'll be 2 times 0.5 divided by 9, which is just 0.1 meters per second raised to the power -2. Right? This is your acceleration. So for B, what are they saying? For B, they're saying, am I going to be, yeah, I think B, I'll be able to write it here. Or should I give you a minute, just internalize everything? Because I'm going to erase it now so we can have space. Sorry. Okay, remember from the previous question, we got our A to be 0.1. Okay, so now they're saying calculate the magnitude of the tension in the string, right? Before anything and everything, we should have drawn a free body diagram of the forces acting on block 3, but let's do it now, right? So for the free body diagram for block 3, we'll have our tension in the string, right? Because it's a string, it has tension. Right, it's like two things are pulling, because this one is pulling and this one it's also pulling as well. So in the middle there's just a whole lot of tension, right? And then we'll have, because remember we said we have tension over here, and then down here we'll have FG. This is the 30 kilogram block. So we're trying to calculate this tension that we have over here. Now let's note we have F, this is for B, right? F net equals to M dot A. Now, if you look at all the forces acting on the 3 kilogram block, it's this tension and it's this FG. You're not going to equate them to 0, because we know once we let go of the 3 kilogram block before it hits the ground and everything, it will have an acceleration of 0.1. So we do indeed have acceleration, and we know the mass as well. So for the so don't try and say F net is going to be equal to 0, right? So for the F net, the total forces on this 3 kilogram block, what is it going to be? Let's choose our up as positive and our down as negative. Right. So what is our upward force? It's tension. Our downward force, it's Fg, right? So we're going to have tension plus negative Fg equals to M dot A. Now we can just substitute in. So we have T plus, what is Fg? Remember, Fg is just mass times gravity, right? So minus, what is the mass? 3 kilograms multiplied by 9.8 equals to, what is this M? It is 3 as well. What is the A? We just calculated for A, so it's going to be 0.1. So now here we'll have T plus, let me just put this into our calculator. It's negative 3 times 9.8, which is giving me minus 29.4. Remember to verify always, equals to what? 3 times 0.1, which is giving us 0.3, right? If you multiply these together, you'll get 0.3. So now in order to get T, which is what we're trying to solve for, we can just say T equals to what? We now have to make T the subject of the formula, transpose this to the other side. So we'll have 0.3 plus 29.4. Therefore, our T will be equals to what? 29.4 plus 0.3, which is giving me 29.7. Remember, tension is a force, so it will be in Newton. Thank you.